Now let's move to the most important subject and in the chapter, which is the percentile. We've always mentioned and talked about the percentile. So percentile is the value that we get after we synthesize or make chemicals. So let's say that I want to like make, for instance, dibenzyl acetone. It's one of the ingredients that is used in the sunscreen lotions. So if I want to make it, all right, I need to calculate the percentile eventually after I got my stuff. Okay, the percentile represent how much chemicals or how much like compounds is the amount that we just made, and then we want to calculate to see how much we make or how much we have already made and compare it with the stuff that is just used like for the reaction. I think like in the beginning of this chapter, I gave like an example, which is let's say that I wanted to like do a reaction and make a medication, okay? And I just got or bought my chemicals, the starting materials, the reactants, and it cost like about $200, okay? After that, the percentage of my reaction was let's say 5%, okay, which is the percentage 5%. And then I just only made like 3 grams, and when I wanted to sell it, okay, I like got only 500, or let's say $2,000. So if we do compare the $2,000 with the $200 that I just get this stuff, so it's a big lose. So I lost a lot of money to make it. So the percentage is really important for our synthesis. So if I want to calculate, so we have some reasons are given to be low. So sometimes when I do a reaction, it could be the technique could affect the result. It could be the impurities in our chemicals. It could be the conditions, the circumstances. For instance, one of the reasons that may has affected our result and stuff like that. So the interaction between reactants cannot be completed. This is the first one. Use of impure, as we mentioned, loss of some products, lack of attention or stuff like that. If I want to calculate the percent yield, there's a law you need to memorize. The percent yield equals actual yield. This is always given in the question. Your job is to find the theoretical yield by using either the number of moles of your stuff, calculate the mass, calculate the volume. All these are going under the theoretical yield. Okay, the theoretical yield means الجانب النظري، يعني المادة اللي انت تسويها بيدك, right? The stuff that you just calculate, do it like mathematically, okay, not in the lab, okay, and times 100%, okay. We will like go through some examples and you will experience that. First example, for the following reaction, we have 2Al, 3Cl2 gives us 2AlCl3, aluminum chloride. Calculate the percentage yield of aluminum chloride obtained from the reaction of 1.5 moles of Al. Mass of actual yield, so this is given, the actual yield. I need to calculate the theoretical yield in order to be able to use the law, which is this one, okay, this law, and then I'll be good to go. Now, what is given here is the number of moles of aluminum, and I want to calculate the number of, or the percentage of this one. So from the number of moles of aluminum, I need to find out the number of moles what of AlCl3, and from the number of moles of AlCl3, I will be finding the mass, and then that's it. Now, the number of moles, as we mentioned, 1.5 moles times this number of moles of AlCl3, 2 moles of AlCl3 from the equation, over 2 moles of Al from the equation as well equals 1.5 moles of AlCl3. This is it. And now from this one, as I just told you to do, we can find the mass of it. So the mass gives equals N, number of moles that we just calculated, times M, which is the molar mass that you need to calculate as well. I think it's given right here. No, it's not given. Okay, so you need to calculate. It's easy, as I taught you previously. It gives you this 200.3 grams. And now we have everything ready. So we have the actual yield right here, 139, and we have 200.3 grams, the theoretical yield that we find it out and calculated, and times the 100, and it gives us 69.4%, which is a decent percentage. So it's pretty good. Okay, this is it. So calculating the percent yield depends on how well you are by like the previous lectures. So if you don't know how to calculate the number of moles, the masses, or the volume of your stuff, then you will not be able even to go through this process or to calculate the percent yield. So you have to understand everything, and then you go through like a question like this. Example 14, which is the last one, CaCO3 decomposes with the heat according to the following equation. What is the mass of CaO? This is the first one obtained. So we need to calculate the mass of CaO. And as molar mass of CaCO3 is 100 gram per mole, and molar mass of CaO is 56 gram, and we have the actual yield, calculate the percent yield. So let's go over each one individually. So first of all, we have the mass of CaCO3, and we have the actual mass of CaO, and we have the molar mass of CaCO3 and the molar mass of CaO. The unknown is the theoretical yield, the percent yield. Okay, theoretical yield is the same that we are going to use in the percent yield. So in order to calculate the number of moles of CaCO3, we use this law, okay, mathematical law, okay, which is number of moles equals 24.8 grams over 100 gives us 0.25 moles. This is the first one. And then we calculate the number of moles of CaO, all right? So number of moles of CaO or CaCO3 times number of moles of the unknown over the number of moles of the known from the equation gives us 0.25 moles of CaO. And after that, we calculate the number of mass or the mass of 0.25 moles of CaO, which is the theoretical product. Mass gives us number of moles times the molar mass gives us 14 grams CaO. This is number one. Okay, and for the number 2, the percent yield, the actual yield over the theoretical yield, and gives us this one. All right, that's all we have for this chapter, and I'll send you the answers of the exercises and for the chapters question, and you will be everything is going to be done, and hope you understand this lecture. And if you have any question, feel free to ask. See you then.